Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss definitions of some important terms pertaining to coordination compounds. Last class I started coordination compounds. Now I am continuing. Now I am going to discuss definition of some important terms pertaining to coordination compounds. Means important terms I am going to discuss. First, coordination entity. Coordination entity. What is coordination entity? That I am telling you. A coordination entity constitutes a central metal atom or ion bounded to a fixed number of ions or molecules. A coordination entity constitutes a central metal atom or ion bonded to a fixed number of ions or molecules. For example, cobalt chloride COCl3, cobalt chloride NH3 whole 3. It is in a square bracket. Cobalt Cl3 NH3 whole 3. Total 6 ligand, 3 chloride ion and 3 ammonia molecules. Total 6 are attached to cobalt central metal ion or central metal atom, you can tell. Then this is the example of coordination entity. In a square bracket, cobalt Cl3 NH3 whole 3 is written, and these 6 ligand, 3 chloride ion and 3 ammonia molecules, total 6 are attached to the cobalt metal. Then this is actually called coordination entity, in which the cobalt ion, cobalt is in the form of ion, okay. Cobalt ion is surrounded by 3 ammonia molecules and 3 chloride ions. Other examples are nickel tetracarbonyl. Nickel and CO, 4 CO are attached to nickel. Second example, platinum. With platinum, 2 chlorine and 2 ammonia is attached. PtCl2 NH3 whole 2. This is in a square bracket. Always entity is written, or complex, you can tell, also called complex, is written in a square bracket. Third example, FeCN whole 6. FeCN whole 6, it is in a square bracket, outside 4 minus. Then this is again entity or complex anion, because it is negative, 4 minus charge is there. Then this is the anion, complex anion. If charge is given according to the charge, you can tell cation or anion. What type of charge is there on the square bracket? On that basis, you can tell it is a cation or anion. Other example, cobalt NH3 whole 6. Cobalt NH3 whole 6, it is written in a square bracket and outside 3 plus. Then this is the entity, also called cation, complex cation. Complex anion, complex cation. This is the complex cation, and FeCN whole 6 in bracket and outside 4 minus. This is the anion. Then I have told you about the coordination entity, also called complex ion, maybe cation, maybe anion. Now, central atom or ion. This term already last class already I discussed. Now I am briefing because this is the right place. Then what is the central atom or ion? Central atom oblique ion. In a coordination entity in a square bracket, you have seen that with central metal atom or ion, some molecules are attached. Correct? Then in a coordination entity, the atom oblique ion to which a fixed number of ions oblique groups are bound. Ions or oblique groups are bound in a definite geometrical arrangement around it is called the central atom or ion. For example, the central atom oblique ion in the coordination entities, you have seen, I am giving example, Ni, nickel, Cl2, H2O whole 4 is attached to the nickel, two chloride ion and 4 H2O molecules are attached to nickel. Then this nickel actually is called central atom. Central atom. Then here one example I given. Other example, cobalt Cl. Cobalt Cl NH3 whole 5. Outside in a square bracket. Outside 2 plus. Then here chloride and 5 ammonias are attached to cobalt. Okay, then cobalt is central metal ion. Similarly, FeCN whole 6. FeCN whole 6 in bracket, outside 3 minus. Then here 6 cyanide is attached to the ferrous ion. Then ferrous ion is called central ion. Then here you have seen in these examples, nickel 2 plus, cobalt 3 plus and Fe3 plus. These are called central atoms oblique ions, and also these are referred to as Lewis acids. These are also called this central atoms oblique ions are also called Lewis acids. Lewis base means it will donate electron. It can donate electron, a pair of electron. As for example, NH3, N has one pair of electron, lone pair of electron. It can donate. Then this is the Lewis base. But some you can say molecules or ions can attract the electron, can take the electron. Then that is called Lewis acid. Lewis acid can take the electron. Then here central metal ion, atoms or ion are called Lewis acid because it can accept the electron, pair of electron. Then this I have discussed about the central atom or ion. Ligands also you are knowing, these ions and molecules which is attached to the central metal atom or ion is called ligands. Here chloride, ammonia, these are attached to the central metal ion. Hence these are called ligands. Now know more about the ligands. Okay. The ions or molecules bound to the central atom oblique ion in the coordination entity are called ligands. These may be simple ions such as chloride ion, small molecules such as H2O or NH3, larger molecules such as CH2 and both side NH2 is attached. CH2, left side NH2, right side NH2. Then this is also a larger molecule. This is also behave as a ligand. Or you can write with N CH2 NH2 3 CH2 NH2 whole 3, just like NH3 3 H are there. Then for each H, CH2 NH2 you can consider. In the place of H, CH2 NH2, ethyl amine you can tell, ethyl amine. In just like in NH3 3H was there, now all H is replaced by ethyl amine, CH2 NH2. This is also called larger molecules or ligand, or even macromolecules such as protein. Protein also can be told as ligand. Protein is also ligand. Proteins also can be attached to the central metal ion or atom. Then protein is also, you can say, larger molecules, or you can tell macromolecules. This protein is the example of macromolecules, big molecules. Now I want to tell more about the ligands. Different type of ligands are there. When a ligand is bound to a metal, ion through a single donor atom, as with chloride ion, H2O or NH3, the ligand is said to be unidentate. UNI, uni means one, unidentate, DENTATE, unidentate. Here I want to tell you H2O is neutral ligands. NH3 is also neutral ligand. They have no charge. They have lone pair of electron but no charge, means no negative, no positive. Chloride ion is negative. Okay. Now other ligands I am telling you. When a ligand can bind through two donor atoms, as in ethane 1,2-diamine. Example is ethane 1,2-diamine. Di means two amine. Ethane 1,2-diamine means CH2 is there. In this CH2, two NH2 is attached. One is in the beginning, other in the end. Both end NH2 is there. Then here CH2 and both end NH2. This is called ethane 1,2-diamine, because two amines are there. First end one NH2, second end one NH2. Two carbon is there, CH2, then one or two. Then with one NH2, with other carbon another NH2. Then this is a example of what? One more example I will tell you. Then C2O4 2-, that is called oxalate. C2O4 2-. This ligand is actually called, this type of ligand is called didentate. Didentate, di means two. Didentate. Okay. And when several donors, here two donors are there. In this ethane 1,2-diamine and in oxalate, two donors are there. Then that's why it is called didented. And when several donor atoms are present in a single ligand, now I told you in a one ligand, two donor was there, two donor at this atom was there. Ethane 1 to diamine, then here two donor atom were there. In one ligand, two donor. Okay, that's why it is called didented. And when several donor atoms are present in a single ligand, then it is called polydented. Example, what I told you, that with just like NH3, 3H removed from the NH3 and its place ethyl amine, 3 ethyl amine joined, CH2 NH2, again CH2 NH2, again third CH2 NH2. Then now here several donors are there, several in a single ligand. This is a ligand. Then only in one ligand several donor atoms are there, and that's why it is called polydented. Then in didented you have seen that. Now example I have given that oxalate or ethane 1 to diamine. Here this nitrogen can also donate, carbon also can donate. Then here this if two donors are there, the didented, C2O4 oxalate you can say. Now two atoms are there, two oxygens are there, both oxygen can donate. And here in ethane 1 to diamine, two nitrogen is there, forget carbon and hydrogen, they don't have lone pair of electron, but nitrogen have a lone pair of electron. Then no lone pair of electron or negative ion, this should be there. Then in didented, now ethane 1 to diamine, two nitrogen is there, both can donate, two atom. That's why it is called didented. C2O4, two oxygen is there, both oxygen can donate. C2O4 oxygens are there, then two atom of oxygen can donate. Oxalate, that is the C2O4 2 minus is called oxalate, oxalic acid. From that two hydrogen you remove, H2C2O4 is oxalic acid. If hydrogen is not there, then 2 H gone as H plus, then obviously 2 negative will remain. Then now they can donate. That's why it is called oxalate is didented. And several donor atoms are, if several donor atoms are present, then it is called polydented. Then example I told you that these things with N 3 ethylamine is attached, then now more than 2 can donate. First with N 3 ethylamine is attached, then that 3 also can donate, because in each ethylamine one lone pair of electron is there, then 3 and one more nitrogen. With that this three group is attached, N, then that N also have lone pair of electron. Then 4 are there to donate the electron, 4 donor atoms are there. That's why it is called polydented. Now another example I am telling you, Iitjee 4 minus. Iitjee 4 minus means ethylene diamine tetraacetate ion. Ethylene diamine tetraacetate ion. Tetra means 4. In these molecules 4 acetate ions are joined. Here you can write easily, very easily you can write this structure is complicated, but you can write very easily. CH2. First you write CH2, both CH2 is attached with single bond. Then now carbon has 4 valency, you know. Then CH2, 2 valence is over, and carbon attached, then one valence is here used, then 3 is over. Fourth one is in both carbon 1 is remaining, then that 1 fourth valence is related to is joined n. 3 valence is there for n, then carbon and n 1 joined, and with other carbon also n has joined. Then now n1 valence is over and carbon 4th valence is over. Correct? For both carbon 4 valence is over. CH2 and one carbon is joined with n and other carbon valence is joined with other carbon. First carbon has 4 valence. Then CH2 2 valence is over. Third valence is with nitrogen. Fourth valence is with other carbon. Same way other carbon, same way CH2 and 2 is over. Third one is attached with the first carbon. 3 is over and fourth is attached with nitrogen. And now nitrogen 2 valence is remaining out of 3. Then now these two are with these 2 valency CH2 acetic acid, acetic acid. You remove H, then acetate ion will remain. Then that this CH2COO 1 minus, that will replace with H, NH3. Then 2, now 1 valence is over, you have seen 2H was there. Then that H will go replace with CH2COO 1 minus. Other valence is third, that again is with same CH2COO 1 minus. Then see, with this one 2 acetate ion joined. Okay, here CH2COO, it came from the state, from the acetate ion it came. Okay, CH2COO 1 minus. Again other CH2COO 1 minus. Then one nitrogen is over. Now second nitrogen, which is joined with second carbon. Then same way CH2COO 1 minus, CH2COO 1 minus. Then total 4 oxygen are having negative charge. Total 4 oxygen is having negative charge. That's why it can donate. It can donate. You can say it is a 4 donor atoms, you can tell. That's why it is a very good example of polydentate. It is called Iitjee, ethylene diamine tetraacetate. 4 acetate ion is there. Then each oxygen has 1 negative charge. Hence both atom, all these 4 atoms can donate. And actually this I told you about the only 4 oxygen donor. But in that nitrogen is also there. Each nitrogen also can donate. Each nitrogen they have lone pair of electron. That also can donate. Then total 4 plus 2, 6. 6 donor atoms are there in Iitjee. Ethylene diamine acetate ion is an important hexadentate ligand. Hexadentate. Hexa means 6. 4 D2 oxygen, 4 oxygen, 1 and 2 nitrogen, they can donate lone pair of electron. 2 nitrogen is there. Then total 6. That's why it is called hexadentate ligand. It can bind through 2 nitrogen and 4 oxygen atom to a central metal ion. Okay, with central metal ion, this hexadentate means Iitjee can bind. It can bind through 2 nitrogen and 4 oxygen atom to a central metal ion. Now more you know. This question is asked. These whatever I am discussing, questions are important. Ligands they are asking. Didentate, unidentate, polydentate, hexadentate example. Then now further I am telling you, when a di or polydentate ligand uses its 2 or more donor atoms to bind a single metal ion, it is said to be a chelate ligand. Chelate ligand. Correct? What is the chelate ligand? Then when a di or polydentate ligand uses its two or more donor atoms to bind a single metal ion. It is said to be a chelate ligand. Okay, that is called chelate, CHELAT, chelate ligand. Question is asked. Okay, the number of such ligating group is called a denticity. This question is also asked. The number of such ligating group, actually big molecules will be there, complex will be sometimes very big. Then in that situation it happens that I told you chelate ligand. The number of such ligating groups means chelating. The number of such ligating groups is called denticity. 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 Okay, means when more this type of ligands, if this type of maybe chelate like ligand I told you, suppose 2 or 3 are there like this, the number of such ligating groups, the number of such ligating group is called denticity of the ligand. Such complexes called chelate complexes tend to be more stable than similar complexes containing unidentate ligands. Means this chelate complexes are stable, are more stable than similar complexes containing unidentate ligands. Okay, if chelates are there, chelate complexes, chelate you can say ligand, if it is there in complex, that will be stable than similar complexes containing unidentate ligands. Okay, now again further I am telling about the ligands. Ligands which can ligate through two different atoms is called ambidentate ligand. Ambidentate ligand, AMBIDENTATE, dentate, ambidentate ligand. Ligand which can ligate means which can bind, which can join, which can make linkage. Okay, then ligand which can ligate through two different atom is called ambidentate ligand. Example of such ligands are NO2 1 minus. NO2 means NO2 nitrite, NO2 1 minus. This is the example of ambidentate ligand. Why? Because here central metal ion can link with N also and with oxygen also. In both way, means central metal ion can make link with nitrogen also and with oxygen also. Then nitrite is the example of ambident ligand. N and O is there, then it can join from both end, from N also, from O also. Second example is thiocyanate, SCN 1 minus. Then here again central metal ion can join with S also and with N also. Hence it is also example of ambidentate ligand, SCN, thiocyanide. Okay. Then here actually the SCN, potassium cyanide, KCN, that is different. It is thiocyanate, SCN 1 minus, thiocyanate. And other this I told you given example for this ambidentate NO2 1 minus, SCN 1 minus ions. NO2 means nitrite ion can coordinate either through nitrogen or through oxygen to a central metal atom or ion. Similarly, SCN 1 minus can coordinate through the sulfur or nitrogen. SCN, it can coordinate through the sulfur or nitrogen atom. Okay. Then thiocyanate is also example, thiocyanate. And here I want to tell you two terms are there, thiocyanate and isocyanate. Thiocyanato, also called thiocyanato or isothiocyanato. How will you tell? When will you tell thiocyanato and when will you tell isothiocyanate? When will you tell thiocyanate? When will you tell isothiocyanate? Actually, it is called NATO, O, in the end you can tell O. Thiocyanato, isothiocyanato. Then here, if sulfur is coordinating to M, means central metal. If sulfur is joining with central metal atom, then that is called thiocyanato. And if N is joining with central metal, then it is called isothiocyanato. Isothiocyanato. When N is joining with central metal, means N is donating the electron to central metal. Okay. Then in that situation it is called isothiocyanato. If sulfur is donating electron, means making bond with central metal, then it is called thiocyanato. Like that way I told about nitrite. Then if N is joining with central metal, then it is called nitrito N. Nitrito N. NITRITO. Always you write O. In ambidentate, always you write O. Nitrito N. It is called nitrito N because metal is joining with N. N is donating electron to the central metal. Lone pair of electron, nitrogen is giving to M. Then M means what? They are d orbitals, back and d orbitals. Then it is called nitrito N. And now when oxygen is donating electron to M, oxygen of NO2, then that is called nitrito O. Nitrito O. O means oxygen. Oxygen is donating. That's why nitrito dash O is written. Similarly, if nitrogen will donate, then nitrito dash N. N means nitrogen. Then this I have discussed about the ligands, and questions are asked. What is the ambident? Example of ambident, example of hexaligands, example of chelate complexes, correct? Didented, unidented. These examples in examination questions are asked. Now coordination number. What is the coordination number? Next term is coordination number. It is also very easy. Number of ligands. Number of ligands joined to the central metal atom or ion is called coordination number. Very easy. If 4 are joining to the center, 4 ligands are joining to the central atom or central ion, then coordination number is 4. If 6 are joining, then coordination number is 6. The coordination number in shortcut is called CN, means coordination number. The coordination number of a metal ion in a complex can be defined as the number of ligand donor atoms. Ligand donor atoms to which the metal is directly bonded. For example, in the complex ion PtCl6. It is in a bracket, a square bracket, outside 2 minus. Then PtCl6, 6 chlorine atom is joined with platinum. And in nickel, NiNH3 whole 4, outside 2 plus. Then here 4 ammonia is joined with central metal, means with nickel. The coordination number of platinum and nickel are 6 and 4 respectively. PtCl6 means coordination number 6 and NiNH3 whole 4. 4 NH3 is joining, then coordination, in this case coordination number is 4. Similarly, in the complex ions, FeC2O4 whole 3. With this iron now 3 C2O4 is joined, C2O4, C2O4, C2O4. You can write FeC2O4 whole 3 outside 3 minus. Then here coordination number is 3. And cobalt, suppose with cobalt 3 En is attached, En whole 3, ethylene double bond, that ethylene is attached with cobalt 3, cobalt En whole 3, outside 3 plus. Then in both cases the coordination number of both Fe and CO is this thing. Here you should remember that coordination number, here C2O4 has 2 negative, and like this 3 are joined. Then for one C2O3 it can 2 atoms are joining. Then now it will tell about 2 coordination number for one C2O4. Okay, ligand is only one C2O4. Okay, but it is joining with 2 oxygen atom. Then one ligand means 2 coordination number. Then here 3 are there. Then coordination number will be 6. Fe is joining with 6 atom. Okay, then how many atoms are joining, that is actually ligand. Then here in this case C2O4, actually unidentate, then no problem. What is the number of ligand? That is the coordination number. But if ligand has 2 multi joining point, multi atom which are making bond with central metal, then that is actually oxidation number. Then C2O4 2 minus was there. Then like that way here C2O4 whole 3 is there. Then 2 into 3 6 bond they are making with iron. Hence coordination number in this case is 6. And here is this thing, in COEN whole 3 same thing is there. Then here in both cases in complex ion C2O4 whole 3 and outside 3 minus, and is cobalt En whole 3 outside 3 power 3 plus. Coordination number of both Fe and CO means cobalt is 6, because C2O4 2 minus and En means ethane 1,2 diamine. Shortcut it is called En means ethane 1,2 diamine. Then here also 2 are there. In ethene 1,2 diamine, 2 from 2 atoms are there, they can make bond. Then 3 are there, 3 into 2 6. Then in both cases, in Fe and cobalt, both are 6 coordination number. And these are called didentate ligands, because each ligand has 2 atoms which can join. Hence this is the example already example discussed. This is the example. Both are the example of di-dented ligand. Means ethane 1,2-diamine and C2O4 whole C2O4 2 minus. Was 2 minus are here again ethane 1,2-diamine 2 conjoin, 2 atom conjoin. When 2 atoms conjoin, then that is called di-dented. Then 3 are joining, the total 6 bond they are making. That's why oxidation, this coordination number is 6. This question is asked, particularly these two question is asked, because only you have to not count the these things, ligand. In case of unidented, it is correct. Number of ligands. Number of ligands, that is the number of coordination number. When ligand is unidented. But if it is a didented, then for one ligand 2 you have to count. 2. Okay, this is the important point I discussed. It is important to note here that coordination number of the central atom, and coordination number will be always of the central atom. Okay, coordination number always will be of central atom or central ion. Coordination number of the central atom or ion is determined only by the number of sigma bond. Okay, only sigma bond. It is determined only by the number of sigma bonds formed by the ligand and the central atom. Pi bonds, if formed between the ligand and central atoms, are not counted for this purpose. If suppose pi bond is they are making central and central ion, central metal ion and ligand, pi bond they are making, then that bond is not counted. That bond is not counted. Only sigma bond, that is actually it is determined by only by the number of sigma bonds. Okay, coordination number, it is determined only by the number of sigma bonds, not the pi bonds. Now next term is coordination sphere. Coordination sphere. What is the coordination sphere? Already you know, but again I am telling you. The central atom oblique ion and the ligands attached to it are enclosed in a square bracket, and is collectively termed as the coordination sphere. Means central atom and ligands together, which you are writing in big brackets, square bracket, then that is called actually coordination sphere. The central atom oblique ion and the ligands attached to it are enclosed in a square bracket and is collectively termed as the coordination sphere. The ionizable groups are written outside the bracket and are called counter ions. Already last class I discussed. Means how outside the bracket ions will be there, that is called counter ions, and this is only ionizable. Complex ions are not ionizable. That is the main characteristics of complex ion. Complex ion, that inside the molecules they will not, inside the molecules are ions present, will not ionize. That is the integral part. Okay, only outside the bracket that will ionize. That is a bond that is due to the primary that will ionize, not with complex secondary that will not ionize. This is the main characteristics of complex ion. Here I want to tell you, if you will do the test, suppose in complex ion, nitrogen is there, nitrogen is there as a ligand, and outside chloride is there, then it will give the test of chloride ion. Chloride ion test it will give, but iron they will give the test. Suppose it is ammonia is related, is joined with central metal is iron. Then they will give only iron test, not the ligand. Ligand they will not give the test because it is not ionizing. It is not ionizing. Okay, it will give chloride test. Complex ion that will not ionize. Hence, it will give the only for the, they can tell the only for chloride ion ability, which is ionizing. It will give the test for that ion only. Then these ionizable groups are written outside the brackets and are called counter ions. For example, in the complex K4 FeCN whole 6, FeCN whole 6 you are writing in a big bracket, a square bracket. Then this is the complex ion. This is the complex ion, 4 negative charge is there, but outside is K4. Then K4 is called counter ions because it is neutralizing. 4 negative charges going to be neutralized by 4 positive charge of potassium. The coordination sphere FeCN whole 6 4 minus. This is the coordination sphere. FeCN whole 6 4 minus is called coordination sphere, and the counter ion is potassium ion. Now, coordination polyhedron. What is the coordination polyhedron? Then this is actually arrangement. This is called arrangement, spatial arrangement. Spatial arrangement of the ligand atoms which are directly attached to the central atom or ion defines a coordination polyhedron. This is called spatial arrangement of the ligands. The spatial arrangement of the ligands atoms which are directly attached to the central atom or ion defines a coordinate polyhedron. Means this is called a coordination polyhedron about the central atom. Okay, coordination polyhedron. This spatial arrangement of the ligand atoms which are directly attached to the central atom or ion is called polyhedron, coordination polyhedron about the central atom. The most common coordination polyhedra are 3. Already last class I have discussed. Last video you can watch also. I have given all this structure of this octahedral, square planar, and tetrahedral. Okay, then these are actually arrangement, a spatial arrangement of ligand atoms around the central atom. Okay, then these are the most common coordination polyhedra are octahedral, square planar, and tetrahedral. For example, CONH3 whole 6 3 plus. Here 6 ammonia is there. This is octahedral. Octahedral. Now here octahedral means central metal will be in the middle. Central metal or ion will be in the middle, and 6 ligands will be there surrounding the metal. 6 bond will be there. Okay, left side 2 bond, right side 2 bond, 1 upside, 1 down. Total 6 ligands are attached to the central metal. Then this is the octahedral. Actually, how will you tell front or back bond? Suppose central metal is in a space, and then suppose that front bond you want to tell you. Front bond you want to differentiate. Bond you want to differentiate by some symbol. Then how? Then it is actually three type of bond you can tell. Three I can say symbols are there to represent the bond. One will be dark, one will be dark, complete dark, and their thickness will start, you can say this near the metal thickness will be just like a point, and towards the L means ligand, their thickness will be more, just like you can tell slightly, you can tell just like angle, triangle, but not big will be there. Base will be not, base will be very less, but it will towards the metal it will be point like that, and towards ligand this breadth will increase little, thickness will be there. That is the one type. That is the dark, complete dark, one representation. And other representation is just like ordinary line. One line you are, for the bond you are writing one line, like that way. One symbol will be that way. And third symbol will be just like a dot. Dot also, in the beginning it will be point, after that again just like a bigger dot, again bigger dot, again bigger dot. Then this is the third symbol. Then this three symbol tells about the three direction: front, back, and side. Okay, front side you can represent with any one, with a dark one. Back side we can tell by this dot. Front side complete front side with ordinary line you can tell, and side you can tell dark, and dot back. In any representation you are telling about the three direction, means front, back, side. Then here 6 ligands are there. Then like that way, complete back and front ordinary line is there. Complete back and front it is telling about one direction. Complete back and complete front bond, that is the ordinary line. And left and right bond you are telling by dark, complete dark. Okay, it is broadening towards ligand. From the points it is begun to broadening, and L it is little more. Okay, then left and right dark line, broadening line. And again you can say these things again back side, left and right again, that is with dot. Like that way its representation is like that. Representation of bond in a different direction. Then generally front, back, and left and right. Then for the left and right, in the back side you can use this dot line, and back and front ordinary line, and left and right complete dark. Okay, this is the representation of bond in different direction. Then this I told octahedral 6 are there, and central metal is in the middle, total 7, including central metal, total 7. That is the octahedral. Now tetrahedral, then 4 will be there. 4 ligand is attached with central metal. Then this like that way, one will be up, and After that, 3 ligands will be, one will be in the can say back side, other will be in the front side, and one will be in the left side. 4 direction, one will be up, 3 will be one left, other right, and other between the two. Okay, then 4 that is called tetrahedral. Already last class I have discussed, and I have also this in video I have sent this structure. And now a square planar, again here it will be 4, and central atom or ion will be in the middle. But now a square planar, all ligands, 4 ligands will be in a square, just less like a square shape. Means 4 points of the square it is covering, and central ion is in the middle, and all are same bond. Okay, ordinary bond representation is ordinary. Only in tetrahedral you can tell 2 ligands are having same representation of bond, same. 2 are same and rest 2 are different. One is dark, other is dot. Now then I told about the octahedral, tetrahedral, square planar. Similarly, trigonal bipyramidal is also there. One coordinates polyhedron is trigonal bipyramidal. Then trigonal, you can understand by that term only. Trigonal means here one ligand this metal will be in the center, and one ligand will be upside and one will be down. Okay, straight line, one above the metal, one below the down the metal. Okay, straight line. And now 2 are right side, one is the 2 representation, dot one, other dark. Then now one more is, actually 3 are same representation, 3 ligands are bonds are same. Okay, up and down, and left side one bond, all are 90 degree, and left side one is making this square, this is not a square, dot, other is dark. Means it looks like a triangle. This dot and dark, if you will just join all, then it will give a shape of a triangle. Okay, that's why it is called trigonal bipyramidal. Means all 3 if you joined, 2 are left side, 2 are there, right side 2 are there, left side 1. Then from the left side if you join these base 2, right side 2 L are there, making some gap, base is there, then an upside. Okay, base is there, then upside is left side. If you join with these 2 L ligand, it will give a shape of triangle shape. And already I told you one is the straight line, that's why called bi. Then one triangle is there and it is taking a shape of pyramidal, then that's why it is called trigonal bipyramidal. Means 5 ligands are there, 5 ligands, 2 are close, making just like a base, and one is above the base, above the metal, and these 2 ligands including these 3 you can make a triangle shape. And already told you 2 ligands are, one is above the M and one that is down, that is a straight line. That's why it is called trigonal bipyramidal. Now one more is there, a square pyramidal. Here also 5 ligands are there, 5 ligands. their arrangement, spatial arrangement is different. All 5, this wherever 5 are there, these are spatial arrangement is different. Then again M, capital M in central metal ion in the middle, a square, and 4 ligands are in the square position. Fifth one is above the M. Then again here it is showing different representation of bond. Means 2 are front dark and 2 are back side. But they are making, if you will join, it will look like a square. And one is above, that's why it is called a square pyramidal. Above means pyramidal. Okay, above means if 4s are there, one above, then a square pyramidal. And 3 and this 5 are there, then 3 is like a triangle shape, and 2 are one above, another down, then this is called trigonal bipyramidal. Bipyramidal is of 2 types. This pyramidal is of 2 types, trigonal bipyramidal and a square pyramidal. Then this I have discussed. Now I am stopping only here. I have discussed shape of different coordination polyhedron. All the things important I have discussed. Other things I will discuss next class. Thank you.